Chinese astronomer Lord Ganymede was one of the first astronomers to compile a star catalogue. Not only stars, but he also documented planets, particularly Jupiter and its moon. One day, while watching the sky, he observed with his naked eye a little reddish dot in the sky near Jupiter. Although it's impossible to see the color of such a faraway object with the naked eye, this little dot was the first observation of the largest moon in our solar system, Ganymede. It was later Galileo who used his telescope to observe Ganymede. Since the 20th century, Ganymede has been part of many science fiction stories that proposed aliens living on it with large equatorial lakes and few human colonies. With the recent discovery of water vapor in its thin atmosphere and underground saltwater ocean, it might be a candidate for life that arose completely independent in the solar system. So let's fly to Ganymede today and learn more about its habitable properties.
Whenever you discover water on another planet, the first thing you think of is life.
Ganymede orbits Jupiter at a distance of 1.07 million kilometers. This places Ganymede about 778 million kilometers away from the Sun. Jupiter and its moons receive less than 1/30th the amount of sunlight that the Earth does, and Ganymede doesn't have a dense atmosphere to trap heat. Ganymede is 26% larger than the planet Mercury. It takes 7 days and 3 hours to complete one revolution around Jupiter. But since Ganymede is tidally locked to Jupiter, the length of the day is also 7 days and 3 hours. Interestingly, there is a beautiful symmetry related to Jupiter's 3 moons, Ganymede, Io, and Europa. For every orbit of Ganymede around Jupiter, Europa orbits twice and Io orbits 4 times. Ganymede has a diameter of 5,270 kilometers, making it the largest moon in the solar system. It is twice as massive as the Earth's moon. Ganymede's outer crust is largely made of ice, particularly water ice, which forms a hexagonal crystal structure. In 2021, the Hubble telescope found evidence of an underground saltwater ocean on Ganymede extending all the way down to the depths of about 800 kilometers, or nearly a third of the way to its center. This ocean would have more water than on Earth. Below that, there's another layer of ice and possibly multiple layers of ice and liquid in various phases until you get all the way down to the rocky mantle, which may itself be in contact with a layer of liquid water. This mantle-water interface at the bottom of a convective ocean would have greatly enhanced thermal temperatures. Further down beneath the mantle, there's a liquid metal core surrounding a solid iron-nickel core with the temperatures reaching 1350 degrees Celsius. The ordinary ice that floats in your drinks is called Ice 1. It's the least dense form of ice and lighter than water. But at high pressures, like those in crushingly deep oceans like Ganymede's, the ice crystal structures become more compact. This ice is so dense that it is heavier than water and falls to the bottom of the sea. The densest and heaviest ice, though, to persist in Ganymede is called Ice 6. Just as we have unique organisms that thrive around and have adapted to the environment surrounding the hydrothermal vents deep into the oceans here on Earth, it's possible that something very similar is happening 800 kilometers down in the ocean on Ganymede. In terms of atmosphere, Ganymede has a very thin layer of it with a surface pressure of just 1 micro-pascal. It would take approximately 100 billion Ganymede atmospheres all piled atop one another to achieve the pressures we have here on Earth, and that might be enough to disappoint you already. Without an atmosphere, after all, why would we consider Ganymede as an interesting world to examine for life? Yes, it's very unlikely that we have substantial life processes occurring on the surface of Ganymede. But when we look at the atmosphere in detail, we find that Ganymede's atmosphere has hydrosignatures in it, and that, my friend, is an important piece of evidence to consider. Did you just see how interesting astronomy is? And with Rocketeers, it can be fun too. Rocketeers make high-quality, solid fuel-powered model rocket kits that even you can launch at your place up to the height of 800 feet. They are the first and only startup who are working on model rocketry in India with solid fuel power. While doing this, they've engaged more than 250,000 students and flown more than 150,000 rockets so far. They have also partnered with ISRO and created awesome merchandise to raise awareness about the works of ISRO. You can order these rocket kits and ISRO merchandise from their website rocketeers.in. Use the coupon code RWOS for an exclusive 15% off on all products. Link is in the description below. Now let's get back to Ganymede. The Hubble telescope observed air glow in the atmosphere, which showed the possibility of an exosphere composed predominantly of oxygen molecules. Scientists believe that oxygen is produced due to radiation as water ice on the surface splits into hydrogen and oxygen. Ganymede also has a magnetic field independent of Jupiter's magnetic field. This permanent magnetic field creates a small region of magnetosphere around Ganymede filled with charged electrons and ions. And due to this feature, auroras in the poles are a common occurrence. Going all the way back to its birth, Ganymede likely formed very quickly from the circumplanetary disk around Jupiter, possibly on timescales as fast as 10,000 years. This allowed Ganymede to retain much of the originally accumulated heat, leading to the differentiation between the core, the mantle, and the icy outer layers. Trapped between a thick layer of ice and affected by a substantial internal magnetic field, Ganymede's thick underground liquid water ocean might provide a spectacularly fertile environment for the emergence of life, which could then possibly sustain itself indefinitely. A computer model of Ganymede's interior created by NASA in 2014 supported the idea of the development of primitive life. Hopefully, future space missions will help us discover more about this icy world. So, did you enjoy this video? Let us know in the comments. Thanks for tuning in to Rocketeers. Be sure to come back for more great information about the wonders of space. Want to learn physics through model rockets? Then check out Rocketeers.in. From DIY rocket kits to launch equipments and everything in between, we've got it all covered.